and I'm a distance learning grad student pursuing software engineering here. I've previously designed and coded a neural network, specifically a convolutional neural network, and the reason I'm saying that is because some of the top teams that participated in the research has used CNN in some form. So let me go ahead and explain what CNN is. It's convolutional neural network. It has multiple layers like this, and then each layer has multiple filters. A filter in this case would just be a matrix of 24 by 24, and then n1 would just be how many filters you have. Now, to get into a filter, let's assume each filter here, each rectangle is focusing on one feature of an image. So, for example, a line like this, a vertical line, would be a filter. A horizontal line would be one filter. A diagonal line like that would be one filter. So each of these filters are focusing on one specific feature that image is supposed to have, and it's going to learn if this image has that feature or not. And if it does, it's going to reward it by making those matrix values true. And then you reduce the size of the filter, and then you pass it through another set of filters, and these filters would be more detailed than the first one. So here it's no longer just detecting a straight line, but maybe a curve. Maybe it's looking for a O, maybe it's looking for a P. So once you get through these and you pass it on, you're going to reduce the size every time, right? Because the smaller, the faster it runs. Um, and then you go through these green dots here, which is basically a loss function. A loss function is what each of these functions are going to have some prediction that it's a stop sign, it's a left sign, it's a right sign, it's a go sign. Well, some of them are going to be true, some of them are not. So if you're not true, then you have to be penalized. So these functions take care of that. And then at the end you will get percentage for each of these, but then stop would have the highest percentage if it's set up right. And that's what these teams are competing for. So let me talk about this team, Sermonet. They're basically using EBLearn, which is an open source implementation of convolutional network. They're using normalized images, size 32 by 32, and it's good to start with similar size for each images, uh, for learning at least. And then these guys got 98.87 accuracy, which is, I think, pretty good. But they figured out that superior networks have been obtained after them with the use of like black and white images. So removing color actually helps learn faster or better, I guess, not faster but better. And then there is this other team that used perceptron on top of CNN. So let me talk about multi-layer perceptron. These are different than CNNs. It's got all these multiple inputs. They're not filters. And then these hidden layers, these layers basically have activation functions. These functions basically would activate if uh, the input is of that type. So if you're looking for a certain thing, it would activate it more than the other if it matches the portfolio, I guess. And then it would give you an output, and you would assume that would be the most probable true output if it's set up correctly. So these team here, IDSIA, they were clever enough to mix CNN and the MLP talked about in previous slide, and then they actually performed better. So they used a single CNN with MLP. A CNN had 7 layers and 42 outputs. Now in this case there is 4 layers, right? So the image is not of that team, but they have more layers, and then they have one hidden layer of MLP with 200 of those units, the activation functions. And then they used bigger image set, 48 by 48 compared to the previous team, and I think that also benefits them because there's more information in that, so you can learn better. It just would be a slower network, but that's fine. Once you learn, it should be fine. So here you can see that they conclude that compared to both of these individually, the mixing them up is better. And then They were trained on HOG features, it's just a side note. We talked about it before. So now I'm going to hand it off to Nihar. He's going to talk about the other teams and how they performed and the result analysis later. Thank you for your time.